Hello everyone, welcome to our today lecture. In our today lecture, we are going to discuss that what is the importance of R-sqaure in Eviews. Basically, R-sqaure tell us that how much variation in the dependent variable due to the independent variable. So basically, when we are estimating any econometrics model in economics, there are two type of variable. One is called dependent variable and the other variables are called independent variable. So in any economics model, we want to check that how much variation in the dependent variable due to any change in the independent variable. So R-sqaure tell us that how much dependent variable are being affected by the independent variable. So this is the basic definition or the basic concept of R-sqaure. So now when we come to discuss the purpose of R-sqaure, that what is the purpose of R-sqaure, as I have already told that R-sqaure indicate that how well the independent variables explain the variation in the dependent variable. So basically dependent variable has no itself value, it is totally depending on the independent variable. If any change occur in independent variable, then it will affect our dependent variable. So that change is measured by R-sqaure. So when we come to the calculation of R-sqaure, the formula for calculation of R-sqaure is 1 minus SS residual and sum of square divided by sum of square of total. So here SSRES is the residual sum of square, the sum of square difference between the observed value of the predicted values, and SSTOT mean that total sum of square. The sum of square differences between the observed value and the mean of the observed values. And when we come to the interpretation of R-sqaure, R-sqaure value ranges from 0 to 1. It is always between 0 to 1. If it is 0, that will be the most extreme case when it is 0 or when it is 1. These both are the extreme cases. When R-sqaure is 0, that is also an extreme case, and when R-sqaure is 1, then it is also an extreme case. So when R-sqaure is 0, it means that our model does not explain our dependent variable. So it means that our independent variables are not affecting our dependent variable. So any change in independent variable will not affect our dependent variable if R-sqaure is 0. So when R-sqaure is 1, that is another extreme case, it means that all the variation in the dependent variable is totally depending on those independent variables which we have included in our model. I will explain these results with the help of an equation later on in this video. So as I discussed that it is the most extreme cases when R-sqaure is 0 or R-sqaure is 1. Most of the time R-sqaure value lies between 0 to 1. So what happens if it is close to 0? If it is close to 0, then it means that there is very less relationship between independent variable and dependent variable. So for example, let's say the R-sqaure value is 0.20 or 0.20, then it means that there is 20% variation in the dependent variable due to those independent variable which we have included in our model. So then it means our model is very weak. And if R-sqaure value is close to 1, let's say for example it is 0.8 or 0.9, that it means that 80 or 90% variation in our dependent variable due to our independent variable, which indicates that our model is very good fitted. So this is how we interpret the R-sqaure value. So now come to the calculation or interpretation in an Eviews model. So this is our model, and I have already calculated this model, and these are the OLS result of an economics model. First of all, we will run this practical example by ourselves, then we will come back to here and we will interpret this R-sqaure values. So now this is our Eviews file, and first of all we have to copy data from our Excel file, and then we have to go file, work file, and then as I have already mentioned in my previous videos that we have to select dated if we have start and end date of data, and if our data is annually then we have to go with this option, and as my data is annually so I'm going with this option, and I have to write start date of my data, that is 1996, and the end date of my data set is 2024. Then I have to go to quick, then on empty group, and here I have to paste my all data. Okay, then we have to select our dependent variable first, and I am going with GDPG with our dependent variable, and rest of all these are our independent variable. Then I have to click right click of my mouse button, then open as equation, and here I have to write C from very first variable. So we are using method OLS, or the ordinary least square method. So here are the results. So it indicates that our dependent variable are GDPG. We have used ordinary least square method. Our sample size start from 1996 and it end date is 2024. Included observation, the total sample size is 29. Here the C is intercept, FDI, GOV and POPD are our independent variable, and here is the R-sqaure and adjusted R-sqaure values which we are interested in to explain these values. Now we come back to our PowerPoint slides so that we can explain deeply that what is R-sqaure is showing to us. So now we will explain that what does this R-sqaure value is showing. As previously we have discussed that if R-sqaure value is close to 0, then it means that our model is not good fitted, and there is very much less variation in our dependent variable due to our independent variable. As you can see that here our R-sqaure value is 0.01, which means that our model is not good fitted. Our independent variables are not explaining our dependent variable. So it means there is only 1% variation in dependent variable due to these three independent variable, which means that our model is not good fitted. So but as you can see from these probability value also, as you can see that FDI probability value is 0.76, which is greater than 0.05. GOV value is also greater than 0.05. POPD value is also greater than 0.05, which means that all these three independent variables are highly insignificant. For significance, the probability value of all these independent variables should be less than 0.05, but in this case all these variables are probability value greater than 0.05, which means that all of these variables are highly insignificant. So this is the reason behind that R-sqaure value is very low, as our all independent variables are highly insignificant. So when our independent variables are highly insignificant, how can they bring any change to our dependent variable? So here is a very generic model which shows that y is our dependent variable, alpha 1 is the coefficient of our first independent variable, which is x1, alpha 2 is the coefficient of our second variable independent variable, which is x2, alpha 3 is the coefficient of our third independent variable, which is x3, and here is the main thing, summation IT error term. Basically error term shows that error term shows the variation of that much which we have not included in our model. So in this model we have included three independent variable. So these three independent variable are affecting 1% to our dependent variable, and 99% variation comes from error term of those variable which we have not included in our model. So for the optimum level of the model, or for the significance of the model, R-sqaure must be higher. So if, let's say for example, if R-sqaure is 0.90, it means that 90% variation in your dependent variable is because of these three independent variables, and only 10% variation in your dependent variable is because of those variables which you have not included in your model. But in this case, what is your R-square? Your R-square is 0.01, which is 1%. So it means 1% variation in your dependent variable is because of those variables which we have included in your model, and 99% variation in your dependent variable is because of those variables which you have not included in your model. So how can you say that your model is good fitted? You cannot even predict a single value on the basis of your results. And we can also explain adjusted R-square. What is mean by basically adjusted R-square? Basically, adjusted R-square shows the effect of those variables which when you include or exclude any variable in your model. So adjusted R-square shows the adjustment of those variables when you include one extra variable in your model or when you drop any variable from your model. So adjusted R-square shows the variation in your model because of those variables which you are including or excluding from your model. So come to the last slide, what is meant by importance consideration or the importance of R-square. First of all, in term of context, if different studies prefer different values. In some studies we prefer that R-square should be greater than 0.80 or greater than 0.7, but in different scenarios it depends on what type of study you are doing. In some cases we say that if R-square is 0.5, which means 50% variation in the dependent variable due to these independent variable, then we can say that our model is good fitted. So it depends on the situation or it depends on the study that what type of studies you are going to do and what type of analysis you are doing. And the second one is the comparison between adjusted R-square and R-square, which I have already discussed that adjusted R-square shows the variation of those variables which we are including or excluding from our model. The last thing comes from from R-square is limitation of R-square. Basically, R-square tells us that how much variation in the model. It does not tell us that whether our models or our variables are statistically significant or not. If we want to check that our variable are significant or not, then we have to see individual variables p-value. On the basis of those p-values, we can say that our variables are significant or not. But R-square cannot tell us that our variables or our model is significant or not. So for the significance or for overall the significance of the model, we have to see the f statistic, t statistic and p-value of the our dependent or independent variable. So this is all from our today lecture. If you have any question, you can ask me freely. Thank you.